Just a little bit of background first of all. So this isn't theoretical; it's an actual project. It's based on an actual project that we did, and it's how we assured quality in a continuous deployment environment. So just to give you some context in terms of the project that it was. So it was a project for a major publishing company. I myself worked for a consultancy. I did, and at the time, and we were sort of tasked with delivering this project for them and what they wanted to do. So it was a project to improve the process to produce publications. There's a lot of P's in that sentence. It's quite a mouthful. I'm saying that after a couple of gin and tonics, or Peronis and pina coladas. So what they wanted to do is they wanted to make the overall process quicker. So they wanted to reduce the time it took from get to the point of an article being sort of provided and actually getting that into a publication. I think the overall process when we started took months, and they wanted to get it down to 24 hours. They wanted more automation, and obviously that helps you out with the first objective there of making it quicker. But also it sort of mitigates manual error, and it just frees your people up to be doing more interesting stuff rather than data entry. And they wanted to provide a sort of better, slicker, more intuitive UI as well. So they were using sort of Oracle Forms, which, if you're not familiar with, is quite similar to sort of Java Swing. And if you're not familiar with those, then the only thing I can say is it's sort of like a formal business old school application. If you were using it on Windows XP, it probably looked pretty tired. So you can imagine in these days, it's positively prehistoric. So they wanted to improve that. In terms of sort of the squad, the team that worked on this, there were 5 full stack developers. Myself and my colleague were sort of tasked with the testing of it. We had a really good product owner who was very committed to the project and was always available. And we had an architect who was very experienced and very skilled and knew exactly what he wanted, which was great for us. The infrastructure for it was built by another squad that started a sprint before us. And they sort of they set up, for example, like the Jenkins agents and server and the Kubernetes cluster. And that was good because that meant that we could just focus on delivering the software, which was great. So a quick note on what we built. We built 3 web apps to support what they were looking to do. They were backed by React. We built a couple of automated sort of back-end UI-less processes. So this is sort of where that automating some of the process comes in. So these would do things like read files from FTP servers, update them, put them back on FTP, perhaps make a REST request. And all this would be triggered sort of automatically, sort of on cron jobs and by reading SQS. So there was no sort of human interaction with this as such. So that was quite a cool thing to work with. And that was mostly written in Java and made use of some of the AWS cloud tools as well, SQS particularly. And behind all of that, there was a load of microservices that supported it, probably around about 30 to 40, and they were Java, Spring Boot. So quite a lot of different tools, technologies, really cool project. There's a little bit of everything, certainly for someone like myself, a chance to play with some microservices, some front-end web apps, and the bit at the bottom really as well, like sort of solve some new problems there with like AWS and a couple of other things. But what was really cool about this project was that it was the first project I worked on which made use of continuous deployment. And I'm going to talk terminology now because it's quite important to get the distinction right with this. Sort of talking to someone the other day, and they were talking about the CI/CD pipeline, and what they were talking about to me was just a CI build basically. And I think the terminology can get used, quite differently, interchangeably in different areas. So I appreciate a lot of you probably sort of know this, but I just want to sort of cover and make sure we're all sort of clear on some of the terms. So continuous integration is the practice of developers merging changes back into the main branch code as often as possible. And then it's validated by running some automated checks. Fairly straightforward. Continuous delivery builds on that because now you've run those checks and you validate that the thing works. What this now does is it automates the creation of something that's deployable, an artifact. So that might be, I don't know, a Docker image or a jar file or even a zip file, etc. Um, well, and obviously once you've got that, then you can then deploy it. But to deploy it is still a manual step. So the second of the CDs, continuous deployment, which for obvious reasons can get used interchangeably and mistaken for continuous delivery, is where you actually take that now one step further and you actually do deploy it automatically as part of that process. So you're taking those artifacts that you built and you are actually deploying them, and you're removing that manual release step. There's a really cool diagram here from Atlassian. I'll put a link at the bottom there so you can sort of have a look at that, and it'll talk about this in more detail, obviously. But that sort of illustrates the key difference, really, which is really important. So you can see on there's two flows there. They both use continuous integration. The top flow is a continuous delivery flow, and you've got that manual step where it deploys to production. Whereas the bottom row, it just goes all the way through. Now, that manual step means that you can do a couple of things at this point. You've got options. You could get all your QA team together and say, okay, this release, are we happy with it? Do we want to do any more regression testing, or are we comfortable? You could have a go, no-go meeting, which obviously are quite common, particularly in sort of waterfall, I guess, methodologies. You could do nothing. You could just leave it and actually carry on building, build more stuff on top and later artifacts, and then eventually deploy something in, 10 builds time. So converse that with the continuous deployment, you don't have those options because it's just going out the door. It's done. It's passed the test. It's going to live. So when you think about any and every commit can go to production without intervention. And that's quite a scary thought, really, certainly for someone like myself tasked with the quality on the project. What if something goes wrong? Where's my safety net? And this is the situation myself and my colleagues sort of found ourselves in when we were sort of, embarking on this project and knowing the methodology and how we were going to deliver it. Certainly, very stressful. But chain smoking won't get you anywhere. It'll just make your clothes smell. So we sort of took a step back and said, okay, so what risks are actually being introduced with continuous deployment? What are we now faced with that perhaps we weren't in continuous delivery? What actually is the problem now we've got? And when you break it down, actually, what we sort of thought about was actually there are two problems that we've got really that we are worried about when we brainstormed it. The first is, what if we release without having undertaken sufficient regression testing? So going back to the previous example where you had the orange box, you could sit down with the QAs and go, have we tested everything? Is there anything else that can go wrong? And you can go, oh, actually, we might want to regression test this. You don't have that option anymore because it's going live. The second is that something that we were worried about is, well, what if code gets finished and pushed before we've written a test, for example, and that goes all the way through without being tested? And they were our two real sort of concerns. But once you've identified those risks, you can start to think about how you're going to overcome them. And now someone just needs to tell the business what we're planning. And whoever done that is going to be faced with a look of fear akin to finding a velociraptor in your kitchen. How you overcome that is another story, and not one I'll cover in here. So going back to our problems, okay, sufficient regression coverage then. How are you going to solve that problem? How are you going to make sure that everything's regression tested? And I'm afraid I'm not going to give any prizes for this because there's obviously a straight answer, which is automation times 3 by the looks of it. So within the project, we had lots of automation. We had lots of tests at different levels. I've noted here types of automated tests / checks. There's a lot of debate in the community at the moment about whether there's any such thing as an automated test. The theory being it can only check what you programmed it to do. We're not going to get into a debate about that now, but just note I'll probably use the term interchangeably. And obviously these tests or checks are sort of curated by different individuals. So unit tests, you say unit checks, just I don't think that'll work there. But yeah, so these will be curated by the developers closely. It's quite close to the code they're writing, and they're probably operating in sort of a TDD format as much as possible, or they certainly did on this project. The developers also took care of the consumer-driven contract tests using a tool called PAT. And this was something that we sort of wanted them to use. So we did get a little bit involved with it, but it was certainly closer to unit tests and certainly from a workflow pattern, and much easier for them to curate. If you're not familiar with this tool, it's a really cool tool packed, and it's great for testing microservices. It basically makes sure that you're not breaking anything, where you've got like loads of different microservices. Let's say you've got one particular service that's called by 30 other services. If you change that service, you're obviously at risk of breaking 30 sort of calls to it. And Pact sort of protects you against that and make sure you don't get into a position where you say, oh, 25, but miss 5 out or something like that. So really cool tool. If you're doing any sort of microservice testing, certainly look into consumer-driven contract because it can ease a lot of your worries. And obviously in doing that, it reduced some of the reliance that we need and we had on writing integration tests. We still need to do some. We also curated API tests, end-to-end UI tests. We Java JUnit tests, so these are for that automated process. They were sort of quite a black box. We trigger the process and then validate, for example, what was on the FTP or what was in the database. We wrote a performance test in JMeter, and we did some manual exploratory testing as well. I just want to talk quite quickly on test data because that is something that's particularly important. I think when you're running in any sort of pattern where you've got to build and you've got a series of automated tests that could run, multiple times throughout the day, really. There's a number of sort of strategies I've seen work. You could rely on hard-coded data for your tests. So, for example, you could, make sure there's an account that exists in your database and your test always uses that account. Obviously, the problem with that is that someone could delete that account and then you're in trouble. And, a possible way around that is you could restore the database before running each of your tests, but you need control of the environment to do that. You could use sort of searching to locate your data. So you could, for example, run a SQL query to find an account you need. And that means that you're not at risk then of someone killing your data off. But it does mean that you now start to be writing and authoring complex SQL queries to find what you need. And what you tend to find is that the data that you think you need is actually more intricate and complicated than you think. So to give you an example, let's say you just need an account, any account will do. You search, select top one from accounts table. But then, I don't know, after 6 months, you find a test fails because although it's got an account, the particular customer on your account has a flag against them. So you go, okay, we need to update the query. We need, top one from accounts where customer not in the flag account, flags table. And over time, these queries become really complicated. And eventually what will happen is you get to a point where you run a test and it just can't find the data you want. So doesn't scale massively well. And the last option, which is probably the best, but also the most difficult setup, is to generate the data. Particularly if you're dealing with a new database that's not got a lot to it, then it's probably straightforward. If you can call some APIs that do it, then great. If you're dealing with what we were dealing with, which is we had a really complex legacy database where an entry into a table actually relies on other entries in 10 other tables underneath it, it obviously becomes a much bigger task. So we were integrating with an existing Oracle database. We couldn't rely on hard-coded data because we didn't have control of the database. We couldn't search for the data because what we were creating had a lot of new flags and new data, so it just didn't exist. So we were stuck with the last option, really. So what we came up with was a test data framework to generate the data as and when we need it, and it could tear it down as well, so it would clean up after itself. We actually got quite a bit of pushback on it because it was such an effort to do. But without it, we wouldn't have been able to accomplish what we were able to accomplish. And, sort of, I think everyone that looks back on it now that probably pushed back at times says, yeah, that was the right decision. So sometimes you have to go through the pain and fight those battles to get the result. I'm quickly going to just talk through I'm not going to show any code or anything like that, but I'm just going to quickly talk about some of the tools and the patterns that we used in the framework for the end-to-end UI tests. So we used an open source tool called Serenity BDD, which is completely open source, so it's free to use, and it's a Java-based framework, and it provides a wrapper around Cucumber, Selenium, and Rest Assured. And what it means is that it takes care of configuring all those dependencies for you and lets you concentrate on writing the tests, which ultimately is test engineers is what we want to be doing. It also has built-in test reports that out of the box HTML, which look really cool, that all make the stakeholders quite happy. We had parallel test execution. We did cross-browser testing with Browser Stack. And something that was quite important to us, because obviously at the end of the day, any testing project is still a software project. It has to be maintainable. So we made use of several design patterns. Where we needed to construct complex data or objects, we used the builder pattern. I think anyone that's wrote any form of automated test is probably familiar with the page object pattern, which abstracts away details of web pages. Perhaps a lesser known design pattern that we made a lot of use of is the strategy pattern. If you're sort of writing automated testing, not familiar with it, I would recommend sort of reading up on it, because it is a great pattern that sort of gets rid of a lot of if statements in your code. We used it in lots of places, but probably the place where we used it, where we got the most benefit, was when we were switching between running the test locally or on against a dev or sit environment. When we were running the test locally, to create the data, we just needed to create a file with JSON in, and then whenever the app would then just read from that file for its mock calls. Whereas when we were running against, in a proper environment, we needed to inject data via SQL queries. And the strategy pattern sort of managed that for us at runtime, so that all we need to do was create sort of our data objects. And then finally, the screenplay pattern. So Serenity supports this quite a lot. There's a lot of sort of handy methods that enable you to use this. It's quite a cool pattern, and it means that you can focus more on users of the system rather than the pages. And it's all about users and interactions, which I think is a great sort of way to think about your test, really, rather than just, I need a page object and then I need to think about how, what methods to sort of use. It's more about the users of the system. So in terms of the automated checks themselves, each one was small, atomic. It tested one thing. It only checked, each test one assert. They created and tore down their own data. They were very focused. So this is often one that causes some debate. So for example, they would log in programmatically and jump straight to the URL of the page they were performing an action on. To give you an analogy of that, imagine if you're writing tests for an e-commerce site and you want to test the add to basket functionality. What you could do is you could create a test that goes to the homepage, clicks login, enters the username and passwords, clicks submit, gets back to the logged in homepage, clicks search, searches for a product, clicks the product, and then you're ready to add the item to the basket. There's a lot of steps to get to that point. And that means a couple of things can happen. One, your test is very bloated. It's going to take a long time to run. If all of your tests like that and you've got 100 tests, your build is going to take hours. Second of all, there's more opportunity for something to go wrong. And you might say, well, hold on, this is a test framework. You want to find that out. But to give you an example of that, in that example there, what we want to test is add to basket. If we ran a build with 100 tests, you'd probably find that 99 of them would fail if login was broke on login, and that doesn't really tell us anything about add to basket. What's better to give you more information is if you've got sort of one test that fails login and then one test that fails add to basket. If you don't have that, what you could do is after an hour and a half, probably longer, because your tests will timing out. You get the test report and you see that everything has failed on login. So you fix login, you run the build again, it takes another hour and a half, and this time you find out that search has failed. So you still don't have that information. So it's quite important that the test was sort of focused and gave us exactly what we needed to know. They had lots of login and a clear reason for failure. So a useful metric is mean time to resolution. And what this sort of is an indicator of how long it takes you to sort of start resolving a problem from the point of you reading the test report. I worked on some projects where you get a build fail and you'll spend the next 40 minutes trying to work out what's gone wrong, which obviously is not ideal. What you want to know straight away is, well, what has gone wrong and what do I need to do to fix it? And they were also authored to be run in parallel. So I mentioned obviously the test ran in parallel, and we didn't do this from the very beginning of the project. We did it sort of 3-4 months down the line. And what that meant is sort of 3 months down the line, we then had to configure it and turn that on. But because when we'd sort of started writing this process of writing the tests, we'd considered that and we'd made sure that each test was idempotent and atomic. When it came to doing it, we just turned it on and it worked. And remember, you can't automate everything. Hold on, no. That last point, you can't automate everything. It's quite an important one. Because of the nature of what we're doing here, if you can't automate everything, then you've got a gap in your regression coverage. You know, we don't have the option to go and perform some manual regression anymore. So anything that's not being automated is effectively just going to go through straight to live. So we looked at a couple of, you know, when we were trying to come up with sort of how we can check some of these things, we looked at a couple of different things. Perhaps testing at a different level. So rather than a UI test, perhaps we could do it at sort of an API or a unit layer. Perhaps looking into new tools and libraries. I was working on a project recently and we needed to validate an image. It was a HTML canvas element, which you can't really interact with. So we sort of did some research and spiking, and we found a tool that would enable us to compare images and match up pixels. And obviously, you've got sort of visual regression tools out there that can support, you know, some of those more difficult scenarios like that. Using mocks. I mean, this is quite common. A lot of test frameworks use mocks, but in particular, this is useful where if you're interacting with a third party, you know, you perhaps want to have a negative test about what happens if you make a call to that third party and responds with a 500. You know, are you handling that properly? You need control of that to do that. So that's where a mock comes in. Test spies are quite closely connected to that. Perhaps an underutilized tool in a tester's arsenal. So test spies sort of build on mocks, and what they enable you to do is to interrogate how your mock has been called. I'll give you an example of how we use this in this particular project. So in those automated end-to-end processes that we had, which we were sort of testing in a black box way, we might trigger a process. So it would need to go and get a file from an XML, read some data from it, and then make an API call with it. Because that API was a third-party API, within our test, we wouldn't necessarily know whether it had been, you know, called or not. So we mocked it. And then what we did is we added another endpoint to the API, which would give us back the last 10 requests that had been made to it. And in doing that, then we were able to ascertain that our test had made a call with the data as we were expecting. Sometimes you need to validate elsewhere. So perhaps an API, a database layer, a little bit more difficult, but perhaps even if you can access the logs of the system, that might give you something that you need to validate something that's happened. But most important thing, I think, is to consider testability when you're refining the ticket. So perhaps in your backlog refinement session, you know, think about, well, how are we going to validate this work? What are we actually going to do? Rather than get into sort of the day when you're trying to write the test for it, if you thought about it up front, you might have been able to come up with, or thought, okay, we perhaps need another ticket to spike a technology that will enable us to do this. So I think our job isn't to compose Selenium checks, it's to enable quality. And in the new world, we perhaps need to think differently about how we can do that. So that was sort of automation, how we handled that. I want to talk about the pipeline now. So we actually use Jenkins for our builds. Obviously, other tools are available, Team, City, Circle, CI, etc. But we use Jenkins, and we watched it like hawks. In the stand-up every morning, we would look at the Jenkins board and make sure everything was green. If it wasn't, then we'd make sure that someone was fixing it and sort that there and then. We would have Slack notifications if the build failed, and we would, you know, immediately within that Slack sort of channel, make sure someone had put their name down to fixing it. And effectively, if a build was broken, it was a stop the line process. The most important thing you could do is to fix that build, and it was a case of drop tools and go and deal with the build, basically. So coming back to our risks, then our second risk, if you call, was releasing before testing was complete, and that was our other big concern. And we built a mechanism for that in the pipeline. So what we did is we, first of all, enforced strict branch naming within Git. So when a developer creates like a branch of code, we enforced what the naming convention for that was. And the idea was that it would be prefixed with the Jira ticket number. So in this example here, Jira 216 login feature. Anything that didn't match that pattern would be rejected, and they couldn't create that branch. Within our test, then we tagged our test cases with that same prefix, so at Jira 216. So there you can go. You can see there's an example test scenario there. So for a login, so giving them on the login screen when they answer credentials, and I'm presented with the home screen. And then what that meant was that when we were executing the test in CI, the pipeline would pick up the branch prefix, Jira 216, and it would call that as a tag to our tests. So any tests that are tagged with that would run. If no tests were executed, then the build would fail. And that was it, problem solved. So that's how we dealt with it. Really simple, really easy to use, and really effective. Flaky tests. So there were a couple of instances where we had flaky tests, and they are the absolute enemy of CD. From my experience, there's a couple of common causes. You can have flaky selectors in UI, relying on other tests, relying on data being in a set format. So coming back to that, for example, hard-coded account numbers earlier, using improper weights, differences in the CI environment versus how you'll run them locally, particularly if you're perhaps writing the tests on a different operating system to what the CI server is. And then not to be forgotten is configuration errors or bugs in third-party tooling. We actually had an instance on this where we were running some tests in browser stack against IE, and for some reason we just get random failures. Couldn't work out why. When we turned the video recording on and watched back, what we actually found was that an error, a dialog box was coming up on the operating system in browser stack. So we raised the ticket with browser stack and they promptly fixed it. But so, not necessarily always your sort of tooling that's the problem. A couple of, whenever we came across them though, flaky tests are very notoriously difficult to sort of fix because you can run it 10 times and it won't happen, yet you run it the third time on CI and it will. So sort of whenever we came across them, some things we tried to do was added in lots of logging around the area, try and turn on video recording. I mentioned that's how we found the browser stack issue. I think the most important thing is that there is always a reason for it. It seems like there's not, they're just, it fails for no reason, but there is always a reason. And if you can work out what the pattern is, you're a good sort of portion of the way to discovering what the actual problem is. So, whether that be the time of the execution, perhaps something's running on the server, what tests run immediately prior, perhaps they do something to the data or the system and put it in a state that's undesirable. And then, things like your browser, your CI server, or your state of your data. There is always a pattern, and if you can find out what that pattern is, you're a good, way to resolve the problem. So to summarize the CI builds, it would fail if we had code that wasn't accompanied by tests. We had lots of alerts and visibility of when things went wrong and made sure that it was visible who was fixing it and help them out if they needed it. We do the daily stand-up checks. We addressed flaky tests. We were really sort of focused on the performance of the pipeline. We wanted to clear errors and we wanted a good mean time to remediation. Myself and my colleague got quite heavily involved with writing Jenkins files as well. I've worked on projects before where sort of QA doesn't get involved with the build sort of configuration. But I think it's a really important thing to do because it sort of empowers you and you sort of learn the art of what is possible. So for example, the convention that we had to prevent the untested code going through, we were able to contribute in the solution to that because we had a good understanding of how it worked. We quite often optimize long running tests as well. Sort of every week or so, we'd have a look at the test report and see which top 10 tests were running the longest. And if we could, we'd try and, refactor them and try and get them running quicker. Because ultimately, if you've got lots of builds that are all taking a long time to run, you can get in quite a mess. So if you've got short, quick builds, that's really important. And what was quite interesting was that we moved from a fear of failure to sort of push it and see if it builds mentality. I remember when the dev lead committed the first push that was going to be going through the pipeline to live. And there was almost a, oh, wow, you're doing this now. This is quite scary. And everyone sort of huddled around watching him commit the code. But as time moved on, we really moved away from that. And so we had so much trust in the pipeline. It was a case of, wow, just push it and see if it builds. If it doesn't, we can fix it. It's amazing how quickly that sort of confidence comes around. So probably the last section I want to talk about briefly is discipline, because I think it's really important on a project like this. We adhered to stand-ups on time every day. They were always short and sweet. It was exactly the same time. The first thing we did was cover the Jenkins dashboard, and then we'd individually give an update on what we did yesterday, what we're doing today, and if there were any blockers at all. Each person took less than 30 seconds. I've been on projects where each person takes 5 minutes, and it's, you're bored and falling asleep. We adhered strictly to a definition of ready and a definition of done. You couldn't bring a ticket into the sprint if it didn't meet the definition of ready, and you couldn't close a ticket until it was in live, which was our definition of done. We would swarm to get issues over the line, so particularly towards the end of a sprint where you're trying to close off those tickets and get them done, we'd help each other out rather than going and picking up a new piece of work. And we'd adhere to all the Scrum ceremonies. We did 3 amigos on every ticket. The product owner was very heavily involved and also input quite heavily into the BDD scenarios, which was great. We did backlog refinement. It used to be 2 hours a week, so we'd book out a 2-hour session. Everyone complained about it and everyone groaned. But it was really important because everyone estimated, and we all sort of, were able to really refine the tickets. And a mantra that we took in was, if you don't know how you'll test something, you have no right to start developing with it, which is something that I learned from a really good developer a while back. We demoed everything as well, and we thought about throughout the sprint what we're going to demo. We actually rotated the Scrum Master, and on one of the iterations, it looked like we wouldn't have anything to demo when I was a Scrum Master. So just because of the nature of the work that we were doing, it wasn't particularly interesting. So I went and spoke to the stakeholders and I said, look, guys, the work we're doing really doesn't lend itself to much of a demo this time around. And they were fine. They said, well, look, don't worry. You're one of the few teams that does demo regularly, like on every sprint. So just missing one isn't really much of a problem. So I said, okay, great. So I went back to the team and said, look, guys, I've had a chat with the stakeholders. Don't worry about a demo. They've said it's fine. If we miss this one, not a problem at all. But the team, what I thought was great, was refused and said, well, no, we're going to do the demo because, that's what we do. And we didn't want to get ourselves into sort of, this a pattern and let standards slip, which I thought was great, and sort of showed a little bit about the mentality of and the discipline of the team, really. All the retrospectives had actions, and we followed them up and verified them in that we'd actioned them in the following retro. And we were quite strict on the velocity as well on our points. So towards the start of the project, we were taking about 40 points in, and we got better at estimating and better at understanding the technology in the stack. So sort of towards the peak, we were hitting 90 points, which was great. So all those things we did it work? So all the discipline and the automation and the rigid pipeline and the really keeping an eye on it. This would be a very odd talk if it didn't work, wouldn't it? So we actually started out using feature toggles. So this was sort of to satisfy the business really and the stakeholders. And we said, well, look, what we'll do when we create a new feature, we'll hide it behind a feature toggle and then you can turn it on. It's a lot of maintenance because what you're introducing is lots of if statements. You need twice as many tests because you need an if the toggle's on, if the toggle's off, and then you have to remove it, otherwise you end up with technical debt. Over time, as we built confidence and the business became confident with what we were doing, we were able to cut all that out and we were just going straight to live without sort of hiding stuff behind toggles. Urgent new features, we were able to get sort of 0 to done in a matter of hours. So the product owner came to the sprint one morning following a release the previous day. So someone had gone through and said, oh, I've seen that new feature, that's great. The only thing is there's something else that we forgot that we need to do as well. Is there any chance we can do it and bring it into the sprint? That was in the stand-up. By lunchtime, people were using the new feature in live. So it really enabled us to turn around and start, getting things out the door much more quickly. The team was really heavily motivated. It's probably one of the most motivated I've been in my career, and I think the other guys on the team would agree with that as well. The client carried out a DORA report, which is a third party that can come in and assess sort of your agile maturity in terms of DevOps. So it's a DevOps research and assessment report. We were one of the highest teams in the organisation, and we were set as a bit of a benchmark really for other teams to follow. So I've put here that we averaged around over 80 deployments a week. Talking to someone that works on the project, we believe the figure's actually close to 100, but I'm going to be really conservative and knock 20% off. So with that in mind, over an 18-month period, that means that we did 4,500 deployments, which is, quite a high figure, really. We had 0 major errors. Personally, I don't think we had minor errors. We had one error where there was a guy in America who was using a version of Internet Explorer and a specific really old version of Windows who had an issue. And ultimately, when his manager found out what he was using, he was given a new machine immediately because there was all sorts of security risks and patches. So we didn't actually need to do anything with that one. And another issue that happened was when you were doing a drag and drop on the web app in a specific version of IE, it highlighted the text. So they were the sort of bugs that we were getting. We did do one rollback out of all those deployments, and that was because someone had committed an incorrect property in the production properties. Obviously, because of the nature of that, it's a property in live that wasn't in any of the lower environments. The only way we would have found that would have been in live, unfortunately. It was caught straight away because on the back of the deployment, a heartbeat check ran, it picked it up, and we rolled it back immediately, so there was no downtime. But if you do count that one, that as a bit of a failure, it's a success rate of 99.9998%, which I think is pretty good. But then I would say that. And I think that concludes everything I had to say, really. There is so much that I wanted to get in that I couldn't because I was just conscious of time. I wanted to talk about, how we won the business round, what the pipelines look like, how we did performance testing. But to be honest, I'd have been here all week, and I'm sure some of you got work to do. So just want to say thank you. Cheers, Anthony and Matt, for setting it up. And yeah, Anthony, over to you.
My mic was on mute. So yeah, I've got some questions here for you. First one from Ian. We had a pact initiative which someone's really wanted to POC. What's the way in? A lot of the pushback was based around reluctance to add to or remove existing automation processes, especially WRT contract validation with Swagger now moving to Open API.
Yeah, so we were quite lucky because this was quite at the beginning of the project for us. Back then, sort of, we started off with Swagger, but it didn't quite do sort of what Pact did. I'll be honest, I haven't looked at the latest that Swagger's doing at the moment, and the Open API stuff. But we quite often did a lot of spikes on stuff. For example, we would, whenever we wanted to implement something like this, we would look at a couple of different tools as a spike ticket and figure out which one will be best for us. I think in terms of if it's a question of, do you want to use a CD framework or not? And given that you've already got a lot of automation, I think the benefits of it do massively outweigh not using it, because I think you get a lot from CDC that perhaps the other tools don't give you. I think it's a different level of test is what I would say, and it gives you a different kind of confidence then rather than just having perhaps lots of API tests. But yeah, I think in terms of, like you say, it sounds like you're sort of looking at a couple of different tools. I think the only thing you can do there is maybe do a spike and a proof of concept on a couple of different ones, and then obviously every team's different. We were advised to use a couple of tools, and we tried to use them. It just didn't work for us with what we were doing in our workflow. And I think doing a spike is just the way forward, and seeing what results you get out of the back of it, and then sort of demoing it in the retro and seeing what the team go with.
Cool. Brilliant. Thank you very much, Tom. Next question is from John Feasy. How did you find the costing model with Browser Stack, and how did you link your tests into Browser Stack?
So in terms of costing, we actually went with one of the lower licenses. I can't remember which one we went with now, but it wasn't. We sort of saw it as quite expensive. So I think we only had like 2 users. And from memory, I think you can sort of run 2 or 3 threads in each one. So yeah, we were sort of pressured into keeping the costs down on it, really. But we sort of found that it worked for us in terms of integrating it. We sort of managed to get it working quite well. We got it working with Serenity. I can't remember whether there was anything specific in Serenity or whether we just sort of had to use the SDK and get it working. But again, it was another thing that we originally didn't use Browser Stack to start. We knew we wanted to do cross-browser. So we did a spike and implemented it as part of the spike just within a sprint. And just, ultimately the goal of the spike was to perhaps not a spike in its true form. That's more of an exploratory finding out thing, whereas we actually implemented it. But quite often we did things like that. You know, when we did performance testing, we just created a ticket to just build a foundation, just get the test running with this platform, and then just building it from there. But yeah, I think it started to creak as we started to scale and grow, because we wanted to run more and more threads. And we sort of, I think towards the end, we were pushing for more licenses. But yeah, we were getting pushed back because I think it's quite an expensive tool.
Cool. Great, thank you. Got a question from Joel Leck. Did you find a way to automate those validations? I.e., if a ticket is ready to bring in but can't move into progress, or just trust the team to not do bad things?
Obviously there's an element of trust. Sorry, can I just refine? Are we talking about bringing a ticket in that doesn't meet definition of ready?
It's a type question, so I've only got limited information. Can you answer that, please, Joel? Yes.
Okay. Yeah. So we were just quite strict on it. So in terms of what our definition of ready was, though, perhaps if I expand on what that meant. So we had things like you couldn't bring it into the sprint unless any supporting tickets were done. So I mentioned earlier about how we'd think about how we're going to test something. If when we were testing, we said, actually, we don't know how we're going to, read an data from an FTP server or something. So we'd say, okay, well, we need to do a spike to plan how we're going to do that in the test framework. So we'd have a dependent ticket. So we'd say, for example, none of the dependent tickets can be done. The ticket can't be done until all dependent tickets are done. There has to be verifiable acceptance criteria. We had wireframes for all our UI stuff that was done by a UX guy. So it was quite a straightforward checklist of things that had to be there before we would bring it into the sprint. And in terms of bringing it in the sprint, we would then discuss that in the planning session. Whoever's turn was Scrum Master would then bring any further tickets into the sprint. And yeah, I mean, we were quite strict with it. There were probably one or two instances, if I'm honest, where we sort of said, well, yeah, we do need to do this in the next 2 weeks, and we will get that thing tomorrow that's blocking us. So sometimes we tended to maybe bend the rules a bit if it just made sense to. But as much as possible, we were strict with it.
Got a question here from Rupi. A moment. Did you get any resistance from business when cutting down tests to turn around builds quicker?
No, because I don't think we ever cut down the tests. In terms of cutting down, so we perhaps refactored them to make them run quicker. We perhaps validated against different things. But no, our tests, in terms of the actual numbers of the tests, that just grew and grew over time. So yeah, we were. It's a balancing act, obviously, but we obviously wanted as quick a build time as possible. But obviously, you have to cover everything, because if you don't, then you're creating gaps in your regression, and it's going to be going live without it. So yeah, so I don't think we ever cut down the checks that we were doing. We only ever added to them, but perhaps we did them in a more performant way, I would say.
Amazing. Got another question from John Feasy. Did you roll back builds or only move forwards? That is for failed builds. You can also add a capture of a screenshot on failure.
Yeah, so we fixed forwards. We didn't sort of roll back. So the rollback I mentioned, obviously, we deployed something to live that sort of broke. So we immediately rolled back to the previous version for a particular service. But yeah, whenever a build broke, we would commit on top with fresh working code. So fixing forward, really, without getting into any sort of pickle with cherry picking commits or anything like that.
Cool. Ian's got a question. I see your hands raised. Ian, do you want to just unmute your mic and ask your question to Tom?
Yeah, hi. I did actually include it in the chat line as well. We've been working through a similar process of dev and test where we've been using CI/CD. We're not actually using, using Serenity. We're not actually using CI/CD, but more and more when people talk about doing exploratory testing in this process, it sounds a bit weird. Do you think there's still a place for it, or is the new way of looking at testing, which is kind of my way of thinking, makes it feel a little bit redundant and a bit, well, why do you want to spend time doing that when you're actually nailing down your requirements and delivering exactly what's being asked for?
No, it's a really good question. Yeah, so in terms of the exploratory side of thing, to give you a bit of an insight on how we work. So when we sort of started a new ticket, a developer would generally pick it up. We might have subtasks under it for development and testing, depending on how you work. What we would do is we would immediately start writing the automated checks for it. Even though we didn't have any code to work with. So for example, if you're adding a new screen, you think, well, that's going to be really difficult because how can you write a test against a screen that doesn't exist yet? But obviously from the BDD and the gherkin, we could start to put placeholders in. We could guess some of the selectors, and obviously we weren't always right, but you could do a lot more than you think. We were talking with the developers all the time. As soon as they had, something in place, we were pulling that down and testing that out. And I think during the process of writing our tests, because we'd sort of done that bit up front where we'd been guessing the selectors and we'd done a lot of the groundwork already, when the developer then gave us something, the changes that we needed to make to the actual automated checks were quite minimal. And what that meant was that at that point then, we would then do some exploratory testing on the branch and just try and break it as much as possible, really, and try things out. So there was definitely still a place for it. Obviously, the downside is that when you're running in the regression suite, that's not going to happen because you can only program the checks you've written. So I think, yeah, there's absolutely a place for it. Did it warrant someone doing it full time, 100%? It didn't, because we were doing it as part of what we were doing, and I think we managed to get it right in terms of our workflow and doing, writing the code up front, and then we could concentrate on just playing around and trying to break it. So I hope that sort of gives you a bit of an answer.
Cool. Great. Okay. So we're going to end it there, guys. It is getting quite late. Conscious some of you guys probably want to grab some tea, or some of you going back to work. So just a couple of things before we sign up. Thank you, fellow QA Babblers, for attending today, making this a great meetup. So we've got another talk coming next Wednesdays. We are doing these weekly. That's going to be with the fabulous Ioana Pokarasu. I'm very sorry if I mispronounced your name. Details will be going up very short this afternoon, but the title is Assuring or Not Assuring Quality. So yeah, there'll be some details on that shortly. We've also got some more events coming up. If you want to check those out for Woodrummers, we do Tech Heads, Time to React, and also UX Meetup in the medical sector. So lots and lots of things on the radar. And as I mentioned, details on Lean Coffee will be going up shortly, probably be up there no later than 2:30. It is limited space, unfortunately, but please do sign up if you can make it. And if we can't slot you in this one, then we've got a record that you are interested in these. So next time you sign up, we'll try and prioritize, try and give everyone as much opportunity as possible to attend one of these Lean Coffees. And also, if you could please do connect with me on LinkedIn, guys. So if you've got any questions or anything like that, or any suggestions. And also, we do need that as part of prerequisite to attend the Lean Coffees. With that, guys, thank you so much. Stay safe, stay sane, and see you next week. Bye.